Well, we can move your computer over.
No, we're good. We're starting. Hi. We're doing rates today, as you can see. And you are going to want to be prepared with your notes and one of these handy-dandy little things, because you're going to find that life is a lot easier to find rates when you have a calculator as a tool.
For our definition for rates, we're still going to be comparing two numbers, like we did with the ratio, because this is a type of ratio. However, it compares different kinds of units. Now, what does that mean, different kinds of units? Let's take a look below at some of the units we have listed. So categories: length, weight, time, money, capacity. So let's go through and talk about different units that would fit in these categories. So for length, I might be talking about an inch. I might be talking about a mile. So those would all be measuring a distance. How about weight?
Well, I know when some people get on the scale, they check how many pounds they are. LB meaning the symbol for pounds. But you could also measure things in ounces.
Next category we have is time. So for example, I might talk about how many minutes I'm using. Or maybe I'm talking about a full day, how many days.
When it comes to measuring money, we can measure money in dollars. We could measure money in cents. Those are a couple of different examples.
Capacity, of course, we know that you 7th graders like your soda, which comes in liter bottles, so measuring some liquid form. Now, what's a rate? What does that mean? We're comparing two kinds. An example would be for if you're driving in your car, how many miles you are going each hour. So we're comparing a distance to time. So here we have, two different categories that we are comparing with our two numbers.
Now keep in mind that all of these are just a couple examples. There are many more ways that we could measure each of these, but we just wanted to give you an idea. So the bottom line to remember is that with a rate, you can't change them to the same units of measure because they are different kinds of units. Miles, for example, and hours, as Mrs. Lesh wrote down, they are two different ways of measuring two different things, distance and time. Let's see how rates should be written when you are expected to write rates. There are three things we want you to jot down in your notes when we are talking about the simplified form of rates.
Step number one, we're going to be writing them in fraction format. So that will look exactly the same as we did our unit on ratios, fraction form.
The second thing that you need to know is that you always want to end up with a denominator that equals 1 unit. Here's where your calculator is going to be really handy. You are going to have your numerator and your denominator. To get a unit rate, or with 1 unit, you are going to divide both the numerator and the denominator by the denominator. That will give you your rate out of 1.
If you have a complex fraction, so you have a fraction, and you have your fraction part, and another fraction, remember we're going to multiply by the reciprocal, the same as we did with our ratios. That way our bottom number will end up with 1.
Then you want to make sure that you keep the units with both numbers. If you say 3 to 5, you're not going to understand what you're talking about. But if you add the units, that's going to give you a clearer picture.
Now another way of saying simplified form when we're talking about rates is to call it a unit rate. And that comes from the meaning of the bottom's always going to be your denominator, 1 unit.
Let's take a look at how we can solve some of these problems. Remember, with a rate, we have 2 different kinds of units. So in our first example, we have 54 feet to 3 seconds. So we're comparing a length to a time. In this case, if we remember our 3 steps, we're going to start by writing a fraction. The first number goes on the top, the second number goes on the bottom. Notice Mrs. Lesh is keeping the units the same. So we're comparing feet to seconds. The next step is going to be to get that denominator to equal 1. Well, the only way to get 3 to equal 1 is to divide it by itself. If we divide the denominator by itself, we have to divide the numerator by the same number so that we can keep this equal. So 54 divided by 3, oh, look at that, how handy is that? Is going to, well, that's not right, is going to give me 18, and 3 divided by 3 is going to give me 1, which is exactly what I want. What we see now is that our comparison of 2 is 18 feet to 1 second.
Remember, we're looking to make sure that we end up with a 1 in our denominator. When you are writing your unit rates, a lot of times you will see them written in this format. 18 feet, a slash, and then seconds. So they'll take the number that's your numerator, and then they'll take your 2 units and write a slash between them, which means 18 feet per second. You can leave it in this format, or you can write it in this format. Both of those would be acceptable.
Let's take a look at our second example.
We are going to the grocery store.
Oh, good. We need to get some caramel.
Oh,
$8.30 for 20 apples. Now, when we are looking for a unit rate, remember we're trying to find out what it would be for 1. And so in this case, we are comparing money to an amount of apples. So we start with our fraction form. Notice that with the top, Mrs. Lesh didn't have any label because the label itself comes in the form of a $sign and the decimal that indicates money. Now we're still going to use our same steps. We want 1 apple so that we can find the unit rate. So we are going to divide both of these by the denominator, which is 20. Let's see what happens. We have $8.30 and we divide it by 20. We are going to get a wang-doodle decimal. We're going to get 0.415. All right, now, since I divided this by 20, that is going to be out of 1 or for 1 apple.
Now remember, when we think of money, money only has 2 places after the decimal point, so it ends in the 100th place. Therefore, I don't need directions to tell me where to round this number when it's money. I know that I need to round it to the 100th place. Because I have a 5 following the 1, I'm going to round that up to 42 cents for 1 delicious apple.
Don't forget your label. And again, it could be 42 cents per apple would also be acceptable.
In that case, remember, no decimal point. In our next problem, we have 2 inches to 3/4 seconds. So I'm going to write it in fraction form first. And when I write it in fraction form, I notice that I have a complex fraction. So I have a fraction within a fraction. I still am trying to have 1 second be my denominator. In order to make my denominator 1, I am going to multiply by the reciprocal.
So that means that we are multiplying both the numerator and the denominator by 4/3. Basically, remember, this is going to lead us to 3 times 4 is 12, 4 times 3 is 12, so that ultimately means 1 unit, 1 second.
Here I'm going to put my 2/1, so they're both in fraction form, so I can multiply.
So 2 times 4 is 8, and 1 times 3 is 3.
Now, in this case, because I have 8/3 of an inch compared to 1/2, normally when we have inches, we'll say how many full inches we have and then how many extra or partial inches we have after that. So I am going to take this number and change it to a mixed number.
And remember, we simply do that by dividing. I can get 2 full 3s out of an 8, and I'm left with 2. So that means we're going to have 2 2/3 inches per second.
So 2 2/3 inches per second.
In our last example on this page, we have 3/5 of a mile for every 1/4 or quarter of an hour.
So when I rewrite this, I'm going to end up with a complex fraction, 3/5 of a mile to 1/4 of an hour. Every time we have complex fractions, remember to make our denominator 1, we're going to multiply by the reciprocal. The reciprocal is 4/1. So Mrs. Armentrout wrote that out. We're going to end up with 1 hour as our denominator, and for our numerator, we'll end up with 12/5 of a mile. Same here, we're going to find out how many full miles and then what partial mile is left over when we write our final answer.
And 12/5 gives us the mixed number of 2 2/5 of a mile per hour. All right.
And last, we have comparing unit rates. So if you are shopping at the store and you come across an item you want to buy, for here we have detergent, and they come in different size containers, well, which one should you purchase? What would be the better buy? So if you figure out your unit rates, you can compare prices. So I want to know how much I am going to be paying per ounce for this item, and then I can compare the two.
In your first example here, because we're comparing ounces to dollars, we are going to start by figuring out our unit rate by writing down, should I go over here?
Sure, go over there.
All right, so we are going to go $4 per 64 ounces. Now, some people might be saying, well, this one's the better deal, it's less money, but notice you are also getting less ounces. And so that is why we have to figure out per 1 ounce. Remember, we want 1 ounce, so we are going to divide
both numbers by
64, which will leave us 1. And then I'm going to take my amount of money, $4 divided by 64, and I'm going to get 0.0625. Remember that money only goes to the the hundredths place, and so we're going to round that to 6 cents per ounce. Let's see how this bigger laundry detergent compares. So in this case, it's $6.75 for 96 ounces, meaning that we're going to divide both sides, or both the numerator and the denominator, by 96. Here's my unit, 1 ounce. And handy calculator, 675 divided by 96 gives us 0.0703, and then it goes on. But this is as far as I need to go, because what this is telling me is that I'm going to be paying 7 cents per ounce. Now, in determining which is the best deal, we now can compare them because they are both in the same situation. This is 6 cents for 1 ounce, this is 7 cents for 1 ounce. When we buy it in this way, we are saving a penny per ounce.
Now usually it's the bigger container that's the better buy, although I know with my context solution that's not true. So, keeping this in mind, remember you want to have them both compared to 1, and then you just can compare your numerators.